It's always like this, the first time. It's harder.
Yeah.
But then it's easy.
And once you've started, you don't think about it, and it's natural.
That's
So it's okay.
it be done.
Yeah.
So, that's easy.
So we're recording. You can
Okay, sure, sounds good. Thank you. Hi, everybody. My name is Yuliya, and I'm an Android tech lead at Jet.com. For those of you probably who have never heard about the company, it's an e-commerce company located in New Jersey, United States of America. And just a few weeks ago, we launched our first AR experience, which was quite a huge success. So today, we'd love to share with you our experiences and how we've gone to where we are currently, and provide some practical tips on how you can bring AR into your applications. But before we actually do a deep tech dive into how we will build our AR experience, let's see what we've done in our company, because most of the examples going forward will be based on our features. So you can see a launcher on the home screen with our application icon. And so after I click on the icon, in my application, I can see a banner. After I click the banner, I need to calibrate in my room, trying to identify surfaces. On the very top, there are different categories that I can choose from. So I need a new Google Home. I'm placing a new Google Home in my room. I can zoom in, zoom out, scale, rotate to read more information about the product. I can tap on it, read more information, add it in my cart from AR experience. If I don't need the product anymore, I can trash it out. And now let's move to some fun, probably, experiences. A drone. So you actually can fly a drone in your room using AR experience. Isn't it fun? So you can use joysticks, bring it to the top, to the bottom, as far as further as you would love to. So AR experience is very limitless, right? So there is absolutely anything that you can do with this. And so let's see how we can actually do all of that fun stuff. But before we actually talk deeper about ArCore, let's talk about its predecessor. So let's talk about Tango. And Tango was that first attempt of bringing AR experiences into Android. So it was very performant, super powerful. It was able to identify irregular shapes. It was really, really great technology. But Tango actually depended on a lot of cameras. So it required some extra hardware, such as wide-angle camera and depth sensing cameras. At the same time, it required a lot of extra sensors to collect the data and provide precise information about the environment that the user is scanning. As a result of these hardware dependencies, the cost of such devices wasn't really cheap, right? And Tango was launched in 2014. Since that time, there have been not so many devices that were supporting AR technology and Tango technology. So just a few to name is Lenovo and Asus. So as a result of all of this, side effects and like extra costs, sensors, hardware dependencies, Tango is about to be deprecated next year. So if you're using Tango, it's high time to switch to something more scalable, maybe cheaper, and technology that is being widespread in the community, which is ArCore. And ArCore does not require several cameras. So, and it doesn't require any extra sensors. So most of the devices that are out there already support ArCore technology by default. So you don't need to search for super powerful devices. As a result, the cost of such devices just average. It's pretty low, like a standard phone cost. And there are quite many devices that already support AR experiences or ArCore technology, which is Pixel, Samsung, LG, Asus, and many more to come. So if we think about augmented reality, I want you to think about two separate concepts or two parts of AR experiences. There is geometry detection and there is view rendering. So geometry detection is all about scanning the environment, checking out what surfaces, planes, what objects are located in the room, and getting this information to us. Getting this information, providing this information to us as developers. And then if we're talking about view rendering, it's more about magic. It's basically taking a camera frame and drawing on top of camera frames. So creating virtual objects that would basically enhance our augmented reality experience. And if we're talking about ArCore, I want to warn you that it's very powerful and performant, and it does its job perfectly well with geometry detection. But unfortunately, ArCore doesn't have anything to do with view rendering. So if you as a developers would love to bring AR experience into your application, you have to think about how you will handle view rendering. So at Jet.com, what we've decided to do, we decided to combine two technologies, ArCore for geometry detection and view rendering resorted to OpenGL. And it was a really nice combination for us. Again, there are different libraries or basically wrappers around OpenGL. So if you don't want to do that hard-coded stuff, you can probably choose a third-party library that facilitates work that currently OpenGL does. In our company, we decided to go hardcore. We decided to work with raw stuff and get more power. That's why we resorted to OpenGL. So if we're talking about ArCore, there are three main concepts that will be very helpful to you as developers. First one is motion tracking, environmental understanding, and light estimation. So let's talk about each and every principle in more details. So motion tracking. ArCore technology is very powerful in scanning the room and trying to identify special points. And in the documentation, Google decided to call them feature points. So you can actually see on the screen those red dots, right? I call them red. You can color them whatever color you would love them to color. In most cases, probably you wouldn't even like to color them, right? Like, because you don't want your users see that, basically scattered image of different random points. But these points are very important. So the movement of these points together with the data that is coming from inertial sensors are very important. And this is what it gives us an opportunity to identify camera position and orientation. If we're talking about environmental understanding, we're primarily talking about planes. So ArCore technology is very smart in taking one camera image and then another camera image, and it's able to see feature points on two camera images, and then it tries to find consistency in movement between feature points. And once that consistency is being found, that's where ArCore is able to fit you in a plane. Again, on the image, you can see I drew a plane as a grid, and there are different ways how you can do this. Again, this is just our custom implementation. There are no limitations on how you want to surface planes. Just two very important things that I would love to warn you about is ArCore, unfortunately, cannot see white planes with no texture. So it's very hard for ArCore to identify feature points on very white and plain surfaces. And currently, you probably won't see a surface. And another important thing that is not being supported, but it's so needed for us developers, is vertical planes, right? Because in our application, we actually wanted to hang a TV on a wall, right? Because most of our AR experiences were built around electronics and products that belong to that category. So not having access to vertical planes or not having opportunity for ArCore to identify vertical planes is a bit painful. But Google promises that they are working on it and trying to support it. So let's see how they will go with that. And the last concept is light estimation. And so what happens is ArCore is very powerful and basically capable to provide us average intensity of the camera image. And again, it's a good example of seeing 3 Google Homes on my floor. So you can see the middle one, and the middle one uses the raw data that is coming from ArCore. So like raw parameter, right? It's not actually incremented or decremented. So it's it provides a very natural sense of realism, right? And on the left side, you can see Google Home, which is super dark and gray. And so this is average light intensity, but decreased by X number. And on the right side, you can see very light, almost bright, Google Home, and this is a parameter that has been, light with a parameter that has been increased by a certain number. So again, it's up to you, to developers, of what you want to do, how you can light your objects, and how you can darken them. So talking about support, ArCore currently is being supported on the API level 24 and above. There are quite a few devices that already support ArCore technology, such as Pixel, Samsung, OnePlus, LG, Asus, and many more to come. And one of the things that you as developers need to keep in mind is that ArCore requires an external application being installed in the used device. And the name of the application is ArCore. Currently it's 45 megs. It's a good thing that we don't need to bundle that code and application within our application. So it's just an external application that users would need to install through Google Play Store. And again, most of you would think, okay, so I'm building my application and then I will expose this AR experience to my users, but what if they don't have this application installed, right? What do I need to do? Do I have to send them back to Google Play and install the application? Fortunately, no. And just a little bit later in my slides, I will share some advices and some really nice and developer-friendly API on how you can do this. So let's do a deep tech dive into how to build AR experiences. And it won't be only about ArCore. So majority of the information will be focused on ArCore, but I decided to do a nice and smooth experience of like where you start with the AR experience and where you end, so that it should be very, coherent and it should be very logical, not just talk about ArCore. So let's talk about ArCore compatibility and installation. There are two types of application that ArCore technology can support. Basically, there are AR optional applications and AR required. And as you can probably guess from the namings, AR optional applications are applications where there are many other functionalities and features that are being provided by the application, but in addition to those features, there is an ArCore or augmented reality experience. And again, just an example is our application. We don't just provide nice and fun, AR experiences. We sell stuff online. So after the users click on a banner, they can land within our AR experience. And if we're talking about AR required applications, we primarily mean applications that support only AR experiences and nothing else. Again, a good example is AR stickers. Really nice application to play around and check out ArCore technology. And why I'm talking about it, it's pretty obvious, right? The reason why I'm talking about it is just because there are some manifest config tweaks that we as developers need to do. So in AR required applications, we have to add a feature, users feature, which is Android hardware camera AR, and set an attribute required to true. And again, it's obvious because this is the only thing that our application does, interacts with camera and provides AR experiences to our users. And on top of that, we have to add a metadata with the name com.google.ar.core and set a value as required. Unlike AR required applications, AR optional applications don't have that users feature, right? Again, just because there can be many other features, they're not really limited around camera use cases. So, but the metadata is still there, and instead of the value set to required, we have to set it to optional. If you think about it, that users feature that we set within our manifest file for AR required applications is very handy, right? And based on that attribute, Google Play Store is actually able to filter out all of the devices that do not support ArCore technology and basically stop serving AR required applications to those devices, right? But if we're talking about AR optional applications, there is not such power, right? Again, just because there are a lot of other functionalities and there is just a tiny or probably big subsection of AR experiences. So, and this is where we as developers need to handle support, right? So this is where we need to figure out programmatically whether this specific device supports AR experiences. If it does, let users into AR experience. If it's not, we have to block it because we don't definitely want to crash our users. So, and there is a really nice and handy API that is provided by ArCore technology. So the thing that we need to do is just to get an instance of our ArCore APK and invoke a method check availability, passing the context. So in here, we are running into two cases. It's either we are getting a result as a transient. So at this point, we basically don't have any guarantees or information about whether ArCore technology is being supported or not. And so we have to invoke the same method again. Or we can actually get a thumb up and we can get basically a result as supported. In this case, you can see that I'm just exposing that banner on the home page, letting my users know that AR experience or ArCore technology is being supported, and letting any users an opportunity to experience it. So we've talked about that external application, ArCore application that needs to be installed in the user's device. And yeah, so again, we have, like, it's our responsibilities of developers to figure out whether, first of all, it's installed on the device. Second of all, if it's not out-of-date version. So, and there is a very nice and developer-friendly API. The first thing that we need to do is to get an instance of our ArCore APK and invoke a method request install. And again, there are two outcomes. It's either we're getting a result as installed, and at this point we know that this specific device has a ArCore external application installed on the device. Or we can land into a block with install requested. And at this point, we know that it's either not installed or it's out of date. And here is where users need to get information about installation process of the external application. And again, we do need to ask our users to leave an application. This specific block, install requested, with the request ArCore install set to false, will lead us to a very nice flow of dialog fragments. So now our users will see a first screen informing them that ArCore application is either out of date or it's not being installed on the device. And then if the users will proceed to the next stage, they will see a very nice mini Google Play window where they will be able either to install it or update, and that's pretty much it. So users don't really need to leave your device. It's a very nice flow that can be done or triggered right within your application. So that's it about ArCore compatibility and installation. And the next step will be to set up our UI components. And so the next few slides will be just OpenGL. Again, just because ArCore technology does not do view rendering, right? So all of the UI setup will be done in OpenGL. Let's see how it's being handled. So there is a really one main component that we can utilize in order to draw elements on, and this is GL surface view. And if you think about it, it's basically like a paint, right, where most of the stuff will be depicted later on. But at the same time, we need to have our brushes, right? We need to have some tooling in order to express what we're about to draw on. And so there is a really nice interface that is provided by GL Surface View. It's called Renderer. So you have to create your class and then implement the interface. And there are three methods that you have to override: on surface created, on surface changed, and on draw frame. If you can probably guess from the naming, on surface created and on surface changed are those methods where most of the setup will be done, or probably clearing up some resources if something slightly has changed. And on draw frame is your core method where most of the drawing will be happening. Quick thing to note is that all of those methods are being run on GL thread, and I actually ran into an issue where I needed to update some colors for my native use. And as we all know, right, updating of native use need to be handled on the UI thread. So I was trying to do it within my method on draw frame, and then I failed. So just keep in mind that you have to go off GL thread onto the main thread in order to draw something. And again, it's just standard APIs, Android APIs, that will provide you really nice methods to do this. As usually is like run on UI thread and some other options. And now the only thing that we have left to do is we are getting in a reference to our Vue.gl surface view. Then we're creating an instance of our ArCore renderer, passing the context, and then we're connecting them. So invoking a method set renderer on surface view, passing our renderer, and that's pretty much it. So our UI components are set up, and here where we need to move to the next stage of scanning the room and identifying what is out there. So geometry detection. And again, just a quick reminder, all of the things that I will be talking about from now on will be solely ArCore technology, except a few slides at the end. So the building a foundation, the main component or building block of ArCore technology is session. And if you think about session, it's just a repository that collects a lot of information for a long period of time about AR system state. And if we look at the code, how we can actually retrieve the session, we can either instantiate it, passing a context, Or if the session has already been created, and usually there is one session, right, per user session, you just can't resume it. So you don't need to create it all the time. To create a new instance, you can just resume it. Quick thing to note is that every time your user leaves the AR experience, you need to pause your session, because we don't want to create performance overhead, right? First of all, camera won't likely work. Second of all, we don't want to collect all of the information, right? So we don't want to create performance overhead within our application. We can just pause it. But here is another important thing to keep in mind is after you pause a session and then resume it and come back within your application, you don't have guarantees that all of the items that have been drawn earlier or detected earlier will be restored. So ArCore does its best to bring all of that information back to you, but we don't have that guarantee. And probably a good thing will be just to communicate that to the user. And again, be aware of it. If we think about session, right, as I mentioned earlier, it's just tons of information, right? And definitely it's just this broad concept that needs some configuration changes or some configuration tweaks. So let's talk about what config changes we have to do. So the first config that user developers have power over is light estimation mode. And there are two options. You can either set it to ambient intensity, saying ArCore that yes, I'm interested in average light intensity, please give me that information. Or you can set it to disabled, and in this case, you will never get this data. Another parameter is plain finding mode. And again, we've touched it a little bit. There are only two availabilities. It's basically you can set it as horizontal, saying that only horizontal surfaces will be detected, or you can set it to disabled. In this case, you're saying, I'm not interested in what is right there. I'm not interested in the geometry that is located around me. And the last mode is update mode. And so this is basically an opportunity of how you're configuring your camera frames and how often you will get it. So there is a blocking mode, which will throttle rendering to usually the camera frame rate. In most cases, it's 30 frames per second. Or you can basically set it to latest camera image. And in this case, you will get, so if you think about it, Android draws at 60 frames per second. So you will get the same image during 2 frames. So it will be repetitive. So in most cases, if you're not doing heavy animation or heavy lifting within your application in AR experiences, you don't need a latest camera image. So let's see how we do that within the code. So we're just creating an instance of our config, and then we're invoking a method configure, passing configs in the session. And as you can see, right, I didn't specify any parameters, right? Like I've just talked about 3 config changes or config options, and it didn't set anything. It's just because this is the default config that is guaranteed to be supported in most devices. So plain finding mode is turned on, light estimation mode is on, and update mode is set to blocking. So this is probably the default option that most developers should go with unless you're doing something specific. So session, probably this is the 3rd time I'm repeating it. Session is just contains a lot of information. And in most cases, we don't need that information, right? It can be, imagine your user is like flying drones within 15 minutes, right, within my application. I don't need that information for 15 minutes. So this is where the concept of frames comes into place. So frame is basically a subset of information that repository can provide within a certain period of time. And this is what you as a developers will be working with primarily. In very rare cases, you will have to retrieve information directly from the session. In most cases, you would love to retrieve it from a frame. So let's see how we actually get an instance of our frame. It's from a session. We're invoking a method update on a session, and we get an instance of our frame. And so what is that useful and valuable information that we can retrieve from a frame? It's a camera, right? And if we look at the code, how it's being done, it's pretty developer-friendly, very nice and easy API, invoking a method get camera on the frame, and you will get an instance of your camera. And what is camera is useful? So camera is useful to get 2 matrices. There will be view matrix and projection matrix. So view matrix basically tries to help you to identify the camera position in the environment, and projection matrix basically provides you coordinates of where on the screen you need to draw certain elements. And I will probably show a little bit of those matrices later and how you can utilize them. But this is what we need camera for. in most cases. Then light estimation. We've talked about it a little bit, so let's not repeat all of that stuff. Let's just look at the code, how it's being done. So we're invoking a method, get light estimate on our frame, and we're getting our float of average light intensity. And hit result. And hit result is where everything gets really exciting and where you actually get some environmental objects that you can play with. And so hit results are divided into two main categories. So hit result is a feature points, right, or a collection of feature points if you think about it. And on the screen you can see all of them are marked with red dots and they're very scattered, right? And on the right side you can see planes. So again, when we invoke a method hit result on our plane, we're getting a list of our hit results. And a list of hit results will either get, not either, it can actually get both, right? It will be a collection of feature points and planes, or planes. Planes are never guaranteed to be there. So, and the only thing that I would love to point out is that in order to get a list of hit results, you either can provide X and Y coordinates, or you can actually provide a motion event. So basically, after the user touches or touches the screen, you can, what ArCore does, it's trying to create a ray, right? A ray from that point of a motion event into a potential collision with a surface, right? So that collision detection information is being provided as part of hit results for you. A very important thing to keep in mind is that planes are considered to be stable, right? They're more stable than feature points. They are less likely to go through some tracking errors or tracking adjustments. And this is what we as developers need to resort to. So after you get a list, you can see a method, get closest hit, and I'm passing a list of my hit results, right? And again, it can be a collection of feature points with planes. And what I'm doing, I'm actually looping through my list of hit results, and I'm trying to get the first plane, because plane is what you want to work with. So try to get a hold of a plane, because you're guaranteed to have more stability and performance. And then if the plane is not being identified or detected, what I'm doing, I'm getting the first hit result, right? You can see the last line of the code, hit result they'll get at position 0. And so, at this point, I know that I am getting a feature point, and a very important thing to keep in mind is that I'm guaranteed to get the closest feature point, right? Because the list of hit results are always sorted in depth by order. So try to work with closest planes, closest feature points, because this is what will give you more stability and performance. So we've talked about frames, and we've talked about three main pieces of information that we can retrieve from a frame: camera, light, and hit result. And if we're talking about the step of actually drawing items, right, and creating virtual objects, ArCore technology advises, and probably strongly advises you, to not work with world coordinates. So some of the frameworks, if you worked with AR experience, will work in a way where you need to work with X and Y coordinate on the screen. And this is not how ArCore works. ArCore actually works with anchors. So what you need to do as a developer is you're identifying a plane or a feature point, and then on the place where you're trying to draw an item, you have to create an anchor. And why is that important? It's important because ArCore technology tries to adjust the position of planes and feature points with time. So imagine if you use just X and Y coordinates, you place something on the top of a desk, I don't know, in the middle of the desk, right? And later on, in a few milliseconds, ArCore technology can adjust the position of that plane, can shift it to the right and to the left. And your object will never be in the middle of that plane anymore. It will shift to the right or left. So in order to prevent such situation cases, what you need to do is you have to create an anchor. And after you set an anchor in the middle of your plane, you're guaranteed that after that plane gets shifted to the right or left, your item will be located just in the same middle of a desk as you put it there. Let's see how it's done in the code. It's very trivial. You're just invoking a method create anchor on a hit, and you will get your instance of an anchor. That's pretty much it about geometry detection. So we've talked about sessions, frames, we've talked about hit results, light estimation, camera, and anchors. So we're able to scan our environments, see planes, feature points, and identify a point where we would love to draw something. So let's see how we're actually drawing items. And going from now on, we'll be talking solely about OpenGL, again, just because ArCore does not support view rendering. So if we're talking about object rendering, we have to keep in mind two concepts, right? Or basically two parts. There is a geometry and there is a texture. And geometry is just a collection of different vertices and information about how you will connect those vertices into a single image. And there are different formats how you can create your geometry files. We used JEDICOM OBJ files. They're pretty standard, lightweight. There is an option of using FBX. FBX is more powerful. It gives you an opportunity to create some fun stuff with animation. So again, a lot depends on your use cases. And texture is basically the surface or material that you would put on top of your geometry, right, on top of your skeleton of an object. And again, there are different formats. PNG is WebPs. A very interesting thing, or fun fact, is not really fun, but at JEDICOM, I was using PNG files as my textures. And I realized that my application bloated to 150 megabytes from like 17 megabytes. And I'm like, wow, this is just incredible. And so being able to resort to WebPs and convert all PNG files into WebPs was able to slim down the application to 35 megabytes. So just keep it in mind. And again, probably most of you are thinking, okay, so you're keeping your assets locally. Yes, we're keeping our assets locally, not because we want to, because it was a time constraint, and our first iteration of AR experiences was just to trying the technology, because it was, when we started to work with ArCore, it wasn't as stable as it is now. So for us, it was more of, MVP and proof of concept. That's why we decided not to create a separate service on the API side. But a good rule of thumb is to offload all of that information to the API side and get all of the assets from the API. So this is just a good examples of how the OBJ files look and how the WebP file look. So you can say Google Home vertices, right? Collection of vertices and points, how to connect them, and the texture on the right side. So now let's talk about how we actually draw elements, right? So as I mentioned earlier, all of the OBJ and PNG files or WebP files are stored in our assets folder. So to work with the texture, what I'm doing is I'm reading first a file from the assets folder and converting that into a bitmap. And then the second thing will be to pass that bitmap into OpenGL. So at this point, my OpenGL knows how my texture would look like. And just because I pass that information to OpenGL, and in order not to create an overhead, I can recycle my bitmap. Similar thing can be done with our OBJ files. Again, I'm reading it from my assets folder, and then I'm converting everything into buffers. So just a quick reminder, OpenGL doesn't work with Java arrays, so that's why I'm reading all of the OBJ data and converting them into the buffers. The next step will be to load all of the vertex buffers. And the next step will be to get all of those vertex buffers and pass them to OpenGL. So at this point, my OpenGL knows about texture formats and OBJ data, right? Now I actually have to connect them. And this is where shaders come into place. So there are two types of shaders. There is a vertex shader and fragment shader. And again, the names speak for themselves. And shaders basically are capable, they tell OpenGL how to draw stuff, how to connect OBJ and, the texture and geometry files. So we're creating our shaders. We're setting the parameters that we're interested in to modify or get access to later, which is texture, light parameters, and material. Finally, we need to draw elements. So this is where most of the heavy lifting is coming into the play. So you can see I'm getting my view matrix and projection matrix in order to calculate the object's position on the frame. And again, this information of view matrix and projection matrix are coming from a camera that we retrieved from our ArCore. The next thing will be to configure some lights and tweak some light data. You can see again the last parameter, light intensity, is that parameter that ArCore is providing to us. Then we're setting the material on our objects. And finally, we are attaching some texture. And that's pretty much it in terms of creating. At this point, we're supposed to have a very nice, hopefully realistically looking object that will be drawn on top of our camera image. So in the next few slides, I would love to talk about something that probably you won't be able to find in the documentation, and something that we've learned from our experiences, things that we run into, things that didn't work properly well for us, basically providing and warning you about certain of those items. So UI guidance. We all know how bad experience is when we're asking our users to onboard, right? Onboarding process is usually a good indication that your application has not been built in the right way, right? If you need to explain to users how to use your application. And this is what we thought we would skip in our AR experiences. We're like, oh, our users shouldn't really need to go through onboarding process. It's very trivial, right? I mean, AR experiences should be natural, right? Users will be naturally able to figure out how to work with us. And then we run into an issue where we let our users to place an item on a certain plane of feature point at early stages of our experience. And then we run into an issue where a user places an item and then an item slightly drifts off the screen, slightly moves around. So an issue with that is that around AR technology didn't have enough time to calibrate the environment, scan the environment, try to find a plane. That's why there have been a lot of adjustments. So at that point, and at very initial stages of AR technology, ArCore calibration process, you're not guaranteed to have a plane. So, and in order to avoid those tracking issues, and in order to provide stability, it's a really good rule of thumb to create a very light, probably overlay, asking users to pan the phone to the left or right and to scan the room trying to identify a plane. And only when the plane is being identified, you can dismiss this item. So it's just, again, a rule of thumb. Nobody forces you to do this, but in order not to frustrate your users with some items being disappearing from your scene or like floating around, it's just a good tendency. If we're talking about performance, so we've touched a little bit on that earlier. Try to detect a plane. If the plane is not being identified, you can resort to the feature point, but to the closest feature point. Please don't rely on the world coordinates. Try to use anchors if you want to draw something on top of your frames or feature points. Don't use more than a dozen anchors because you will start seeing performance overhead. At this point, 12 anchors is basically a good max that you can utilize. Don't use vibration. Vibration is a really nice feedback, right? Especially in your experience when you can tell your users, I don't know, shift to the right, shift to the left, or after you place an item, or we actually were using vibration when we were deleting item from this scene. And then an issue with that is that there are some tracking issues, right? Again, just because vibration shakes your phone, it can cause some tracking errors, so try not to use it. Try to set your camera rate to, camera rate is usually set to 30 frames per second, but try to resort to your update mode as blocking in order not to create performance overhead. And the final piece of advice would be try to log orientation. And I wasn't a fan of that. And I am one of those developers who thinks that if an application does not support portrait and landscape, both modes, then it's not a good indication of the application. And we've always been advocates of supporting both, and we realized that in ArCore it's actually not possible. And if you think about it, as I mentioned earlier, every time we rotate a device, right, the activity is being destroyed, so the session has been paused and then resumed. Every time we pause and resume a session, we don't have guarantees that ArCore will be able to provide all of the information that has been drawn earlier or all of the information that it collected earlier. So you can imagine how bad of an experience it can be when a user places something, uses our experience and then rotates the device and then all of the items got disappearing, right? So not a really user-friendly experience. This is where we decided to log orientation and not to bother about that. Another thing that we ran into, noticed is distance. So when we were giving users opportunity to place virtual objects as far as they wanted, we realized that sometimes a user just moves the item too far away and the item just disappears, right? It's not because there are some tracking issues or AR issues, it's just because it scales down to such a tiny size that the user cannot actually bring it back to the front, like the item is not visible anymore. So this is where we decided to start calculating the distance between our camera position and between an anchor position. So in our case, the threshold is 4 meters. And we're basically trying to identify whether the distance is greater than 4 meters. If it's greater, we don't really reset an item to a different position, right? So it's basically the same old anchor. But if the distance is less than 4 meters, then what we do is we detach the old anchor when we are relocating the item to a new position, attaching a new anchor. Another important thing to utilize and remember is there are different tracking states that are being provided for you as developers by ArCore API. So there is a tracking state, pause state, and stop state. And it's very obvious, right? But I felt like we didn't do much of, like tracking state on our early experimentation, and we've seen just a little bit of performance overhead. And so where does this state come into place, or like where is it important? So sometimes you can create a lot of anchors, right? But most of those anchors, or like some of those anchors, won't be viable, right? They won't be live anymore. So it's a good rule of thumb, before you start drawing something on top of your anchor, right, you have to check its state, because sometimes the state is not tracking, and in this case you don't really need to bother to create something. The same about camera. Try to check its state. If it's pause or stop, then yeah, just don't do anything. Don't do heavy lifting that will impact the performance of your application, drain your battery. So that's it in terms of our ArCore technology. Thank you so much for your attention. Do we have some time for the questions? Okay. I think I see some questions just right there. Yep.
Hi, thank you for the presentation. I have a question about OpenGL. I'm not very familiar with it, and I'm wondering if Google will implement an API for us, or let us do the dirty job.
Great question, and I think this is the right question. And I've checked, as you can probably all know, there were I/O sessions already out, and I'm positive that there will be some type of wrapper on top of OpenGL, and I have a good feeling that it will be announced in May. So let's just watch out for announcement at Google I/O, because you're right. If you think about it, ArCore technology, right, like raw ArCore, is very powerful and like amazing. But at the same time, it's not full, right? It's not full experience, and most developers are really scared of OpenGL. And if you've seen all of the code that I've written, it's just most developers will be like, ArCore is nice, I'm not sure whether I want to learn OpenGL. So I'm pretty sure there will be some type of wrapper that will be created pretty soon.
Hi, I am just asking if you know, is it planned to have the support of the vertical plane?
Yes. So at this stage, vertical planes are not being supported, but Google is talking about supporting it. And maybe this is not the right conference to talk about, but if you look at the ArCore, they currently support vertical planes. So I'm pretty sure Google will do it best to provide support for vertical planes. Yeah. I think they will do their best.
Hello. Did you have any prerequisites for the products to be rendered on your application, like, for example, the dimensions? And did you have to tweak the API's product to do that?
You mean the products, the stuff that we sell, right? So the products themselves, like what are the sizes of them? Yeah, great question. So we actually tried to, every time a user places an item, right, on a plane, we try to depict, to draw the item of the realistic size, of the real size as it is per specs. And but then the users can zoom in and zoom out, like, and scale in, scale out of the product. But the initial stage of all our products is the realistic size of the product. Is that the question? Sorry, did I answer it? Okay, awesome, thank you. I think a question is right in the front.
I think I nodded out.
Sure, yeah, I will repeat the question. Okay.
Wait.
Thank you. Are you able to get the direction of the light as well?
Unfortunately, no. No. But I don't see why it wouldn't happen in the next iterations of ArCore. Again, judging by how our competitors are moving forward with the ArKit and there is directional light, I don't think it's impossible. Thank you. Okay, I guess that's it. Again, thank you so much, and please don't hesitate to shoot me questions if you have any. Thank you.